Hello and welcome to Basic 2 Tech. Today's video, I'll be showing us the calculations on head loss due to laminar flow. This video is the part 2 of head loss due to laminar flow. So if you have watched the first part of this video, you must be familiar with these three formulas. This is the Reynolds number, and right here is the head loss, which is the Darcy-Weisbach equation. And what you see here is the friction factor for laminar flow. We use this formula for laminar flow when dealing with circular pipes. Before we continue, it is important to look at the steps that we use to calculate head loss. If you can understand these steps, you will be one way ahead in solving any question on head loss due to laminar flow. So here is steps. The steps we use to find the head loss for laminar flow. The first step is to find the Reynolds number. If the Reynolds number is a turbulent flow, the next step is to find the relative roughness. Then afterwards, you find the friction factor from the Moody chart. Then afterwards, you can find the head loss. But if the flow is a laminar flow, you use this formula to find the friction factor for the flow. Afterwards, you find the head loss. So for this video, we are focusing on laminar flow. So we have just step 1 is to find the Reynolds number. Step 2 is to check if the flow is laminar or turbulent. Remember, if the Reynolds number is below 2000, it is laminar flow. Then step 3 is to use this formula to find the friction factor. Then we can find the head loss. So please try your best to remember these 4 steps on your left in finding the head loss due to laminar flow. Let's look at a question. Here is our first question. Water is flowing steadily in a 0.18 centimeter diameter pipe, which is 20 meters long at an average velocity of 0.89 meters per second. If the water have the following conditions: temperature is 20 degrees Celsius, density of 999.7 kilogram per meters cube, and dynamic viscosity of 0.001307 kilogram per meter second, calculate the head loss for this flow. So the first thing, or the first step we do, is to write out the given data. So right here is my given data. Now the D is the diameter, which is in centimeters. So I convert to meters by dividing 0.18 by 100. That gives us 0.0018. The V there is the velocity of the flow. The length of the pipe is 20, which is given as L. The T is the temperature. For this question, we don't really need the temperature. The rho is our density, which is 999.7 kilogram per meters cube. This is the mu, which is 0.001307, and that head loss is unknown. So the first step is to find the Reynolds number. So we can either use this equation or we can use this equation. So looking at my given data, we cannot use this equation for Reynolds number because we are not given the kinematic viscosity. But this, we are given the mu, we are given the velocity, we are given the diameter. Sorry, we are given the diameter, and we are given the dynamic viscosity. So we use this formula to find the Reynolds number. The next step is to put in the values. So I put in the values into this equation. So my density is 999.7 times the velocity is 0.89 and the diameter is 0.0018 divided by the mu, which is 0.001307. So when you put all these in your calculator, your Reynolds number should be 1225 to the nearest whole number. Now, this value of our Reynolds number is less than 2000. So that means that our Reynolds number is a laminar flow. So that's it. That's our step 2. Reynolds number is a laminar flow. That means that we can find the friction factor by using this equation. So we can find this, we can use this equation to find our friction factor. What next? We put in a value for the Reynolds number. Reynolds number is 1225. Put it right there. We'll divide this in our calculator. Our friction factor is 0.05 to the nearest to 2 decimal places. So now we've gotten our Reynolds number. 2, it is laminar, and 3, we've gotten our friction factor. The last step is to find the head loss. And to find the head loss, we use the Darcy-Weisbach equation, which is friction factor times the length of the pipe times velocity of the pipe of the flow squared divided by the pipe diameter times 2 times the gravity. So we put in the values. Remember, guys, that our friction factor is 0.05 times the pipe's length is 20 and the velocity is 0.89. Remember, it is squared, so squared divided by the diameter of the pipe, which is 0.0018 times 2 and times the gravity, which is constant, it is 9.81. When we put all this in our calculator, our head loss should be 22.4 meters to the nearest to 1 decimal place. So the head loss for this question is 22.4 meters. Let's look at our next question. So here is question 2. It says, calculate the head loss per unit length. Please take note of these. It says head loss per unit length. So as you can see, this is a different approach to this question. Calculate the head loss per unit length for an oil flowing in a pipe of diameter 25 millimeters at a rate of 0.00034 meters cubed per second if the kinematic viscosity is 0.00074 meters squared per second. Again, the first thing I encourage us to always do is to write out the given datas. So the datas for this question, I'm giving the diameter of the pipe, which is 25 millimeters. So we have to convert these to meters by dividing 25 by 1000. That gives us 0.025 meters. Then this here is our discharge. As you can see, it's in meters cubed per second. This is our discharge, is 0.00034 meters cubed per second. And we are given this time, we are given the kinematic viscosity, which is 0.00074. Again, we are asked to find the head loss. The first thing we do is to write out our Reynolds number equation. Now, we have 2 equations for Reynolds number. This time, we cannot use this because we are not given the value for our dynamic viscosity. But in this case, I can use this because I'm giving the value for the kinematic viscosity. And I'm giving diameter. The only thing missing from this equation is our fluid velocity. But we are given the discharge. So we can find the velocity from the discharge. So we have to use this equation to find the Reynolds number. Before we find the Reynolds number, we have to find the velocity using the discharge equation. If you have watched my previous video, I showed us how to use the discharge equation, which is discharge equal to velocity of the fluid flow times the cross-sectional area of the pipe. So we can find the area of the pipe using the pipe's diameter. The discharge is given to us, so we can just transpose to find our velocity. So when we transpose the equation, our velocity is equal to discharge over the area of the pipe. And the area of the pipe is equal to pi d squared over 4. So what next? We have to put in the values. So when we put in the values, our discharge is 0.00034 over, we have pi times our pipe diameter is 0.025 or squared divided by 4. So therefore we bring back our 0.00034 over, when you compute the area of the pipe, you should get 0.00049. When we divide this, our velocity of the fluid flow should be 0.69 meters per second. Now, we've gotten the velocity of the fluid. What we can do now is to find the Reynolds number using the equation velocity times pipe diameter over the kinematic viscosity. So we put in the values. Our velocity of the fluid is 0.69 from our last calculations times the pipe diameter is 0.025 over the kinematic viscosity, which is 0.00074. When we put this in our calculator, our Reynolds number should be 23. Now, guess what? What kind of flow is this? This flow is a laminar flow. So that means that our next step is to find the friction factor using the equation. So since the flow is laminar, we can use this equation right here to find the friction factor. So we put in the value of the Reynolds number, which is 23 right here. So when we divide 64 by 23, our Reynolds number is 2.78. Reynolds number has no dimension. All right. So that is our Reynolds number. So the last step is to find the head loss. Again, we use the Darcy-Weisbach equation, which is the friction factor times the length of the pipe times the fluid velocity squared over the pipe diameter times 2 times the acceleration due to gravity. Now, remember, we are asked to find the head loss per unit length. Head loss per unit length. So that means that we have to transpose in respect to head loss per unit length. If we transpose head loss per unit length, the equation becomes head loss per unit length equal to the friction factor times velocity squared over the pipe diameter times 2 times gravity. So therefore, when we put in our values, our friction factor is 2.78 times the velocity is 0.69 squared divided by the pipe diameter is 0.025 times 2 times gravity is 9.81. When we calculate when we put everything here into our calculator, our head loss per unit length is 2.7 meters per meters of the pipe. So this is the head loss per unit length for this question. Thanks for watching.